Hello, welcome to this new class. Today we will talk about loading and setting the supports for the boundary conditions, but they are important for a correct analysis because usually we do not set correctly boundary conditions, so we might have incorrect results. Typical loads, single point loads, moments, linear surface loads including gradient, temperature, structural temperature, because heat transfer is included in another field. Even you can couple the heat transfer to the structural analysis. Spectral, where you can add your own user spectrum or use the ones defined by codes. And Prestressing loads as well to define tendons for beam, shell, and solid elements. And very important, the definition of the boundary conditions, the different supports. You will see that depending on the type of support might apply to your model, you will have different results. To have very clear which type of supports you will have and which degrees of freedoms you want to constrain. You can add a single linear surface constraints for displacements and rotations, depending always on the number of degrees of freedom of each structural element, and as well impose displacement. You can enforce displacement to nodes, to lines, to surfaces, and if you want to consider an elastic foundation, you can use springs. We open the software, and this is an example that it's already available in the work examples section. It's a concrete arc made up with beam elements, tapered. As you can see, there are 3 different sections and 4 structural elements. The definition of the arc is explained in the slides. So I want to show you today how to define loads and boundary conditions, and later use these loads or load groups and boundary conditions groups to create different load cases, which will be the combination of these 2 entities. We have our mesh, and in the loads tab we have these different loads, these different loads group, load cases group, and for plot and view the loads, boundary conditions, and load cases defined. But here we have this first button, which is load group. We set any name, and here have this contextual menu, and we can add any type of the available ones: single load, single moment, linear load. They can be applied to points or to nodes. So we can define another load, set the direction. By default is oriented with respect to the global Cartesian, but it can be changed. We can set a vector value, pick one node, example this one. If I want to check, I go here, set it to a linear mesh so we can see the application of the load. If I want to change the location or the value, I can click here and change it to another location, or even modify the vector. For linear loads, you can do the same, just select a line and the direction and a value. Now I see here the point load and the linear load. Here for linear loads, I can change the direction for both ends, the direction and the value of the load. So I can set here double of the value. There will be a gradient in the orientation. As you can see, the orientation of the load in the beginning of the first end is following the x direction, and at the end of the structural element, the direction is following the y direction with respect to the global Cartesian, and this is the point force. Always the resultant of the force at each node will be composed by the rest of forces. Here in this example, always you can check the different forces applied. Here there was a wind pressure following the set direction and was applied here, along with forces which are 3-point. You can see that in the statement of the exercise. 3 forces apply other type of forces, temperature forces, surface loads as well, but we don't have surfaces here. To apply a temperature, just select which structural element to be applied and the increase of temperature in the different units. A gradient of 30 degrees on the full structural element. We have other type of forces, setting an acceleration, same as gravity, which is automatically defined always by default. Gravity must be applied following the direction, so in this case it's the y direction, but with negative value. Other type of load are spectral. You can set a user response spectrum or following the available code. If you select Euro code, for instance, you have different parameters to select, and always you have to set the ground acceleration. And once you click OK, here you have the different tables for the horizontal and can show chart for each damping value. Okay, you have the response spectrum. And for vertical, the same. Here are the parameters that we have selected before. And then, as spectrum needs first a modal analysis and then a modal combination, here you have the options, the number of modes to extract for the modal analysis. And after that, they will be combined using different methods: the square root of the sum of the squares, CQC, and for each direction, you will have as well how to select how to combine them. If you want to take into account other loads, you click on prestress. Okay, prestress loads, you can prestress beams and shells. To do that, you just need a section. Have not defined the section of a tendon, how to define a cable section, casing, how to prestress it. There will be an example of a prestressing tendon soon as well, and just select which entities to prestress. There are no new elements to be defined for the prestressing tendon, but the equivalent forces will be applied to the model. For the prestressing case, there is an example of prestressing as well in the worked examples section. There is another way of, there is a prestress load utility where you have to define just the geometry of your tendon, and here when you define a prestress load, just select the geometry with the tendon and the elements of the host structural element. In this case it's the full beam where the tendon will be inserted. No finite elements will be created, only the equivalent forces. See here. Here you can see the equivalent forces that will be applied due to the effect of the post-tensioning. You have many options here. In case you are going to study a full prestressing, you can calculate losses, long-term and short-term losses, and you can check here both the stress, the forces and the different losses here for friction, or all of them are displayed here. In case you don't want to include losses, you can set them to 0, so you will have the full force applied. To define a surface load, we can go to another example, this one, or any model using shell elements. It's okay as well. If you want to create a new load group, just go here and define a surface load. Example here, you have to select the structural element and then the surface. Okay, you can see that it will be highlighted gray or blue, and set the direction. I want to set a direction normal to the face, so it will be following the y direction, and here I can set a value. I can check here. Here's my new force, my new pressure. It's constant, and we have options here to change each value. Well, the orientation is always parallel to a vector, following the y direction, but can be as well normal to the surface. In this case, it's the same because the surface it's normal to the load direction, but in case you have another shape, it will follow the normal of the surface. The same if you can use the projection or full pressure, but in this case, I want to show you if you want to set. In case you want to set a gradient with a slope, you can set first the location of my zero contribution, here at the top, this curve, or that edge, and set the slope value. In case you want to set it increasing or decreasing, just set a negative value. Here you can see, taking into account the height, one value or another. Okay. Here you have it. So we go now with the important step, which is the boundary condition. How to define a boundary condition? Just set a new group. You can always change. We change the name of the boundary condition, and here we have the different options. If you want to set single node or to align, first you have to select the structural element, and then, as you can see, you can select the different curves of that structural element or the curves of the geometry of that structural element. In this case we selected the solid 3D, but if we want to select one of the reinforcement, we can select other lines. Of course, as in this case, you can select lines or other geometry which not belong to the initial geometry. And in this case, the boundary conditions were set to these two lines, simulating the supports. So you can create lines on the geometry and then later select them as boundary condition. If you want to set a boundary condition, mine here, bottom surface, you just constrain the different degrees of freedom, and to check them, you just go here, click here. If you want to change the surface, click here and edit and choose another. If you want many surfaces, just click Control. We have selected these two lines as the vertical supports. Important thing here is you can define as many different boundary conditions as load groups, but the software will only solve the different load cases defined. Set a load case. Here in the load case, we combine the different load groups that are defined here, the different boundary conditions, and you can add them here. Unless you don't define a load case, you won't have results. So just here in this menu, you can add any of the loads and any of the boundary conditions. You can always create different load cases with different boundary conditions and check results. You have always to define a load case. In this example, there's only one load case, which was the first one. The load was applied as an imposed vertical displacement, and the boundary conditions were the vertical supports. Here you have them. In this, a connection was defined, so there's a vertical displacement of all these line of nodes for both sides, but we can define another load case setting same loads or the gradient pressure example, the last boundary condition defined. And here we can always check. If we go back to the arc, we have two load groups, the wind, lateral wind, and 3-point loads. We can later define different load cases. For example, the first load case was for serviceability limit state, and self-weight, wind, and point loads were applied. And in the load case, we can set factors for ultimate limit state. We can apply factors to the different load groups and then add the boundary condition. And we have defined another combination, and you can see them here. The only difference between them is that in the second one, an imposed displacement was applied here at the final end of the arc, a horizontal displacement of 2 centimeters. And we have another way of defining combinations, which is after solving. You will see that in the next chapter. You can define your own combinations, selecting the individual blood cases without a multiplying factor, and then you can combine them here a name, and using coefficients here. Self-weight, a load case for wind load, a load case for seismic load, or a load case for live load, etc. And then you will create another result file. That will be explained in another chapter, another class, the next one, how to create envelopes, combinations, special results, which will be a kind of combination of the ones already available in result files. Okay. The types of loadings and boundary conditions are explained. For the case of displacements, it's the same. You can set displacement to nodes, lines, surfaces. Here, a displacement was set 3 centimeters
in X direction.
Here, following the positive X direction. The displacement of must be allowed. You can see here. So we have finished this class. Thank you again for attending, and see you soon.